Now we are open for the question and answer. So can I have the question from the floor? Okay. Let me read to you the question for Raymond Tan from Hill Mendoza. It seems to me that the P-graph network can be optimized using the branch and bound algorithm. I think you may have done this. Can you give us a sense of the size of the network optimized by accelerated branch and bound? MSG to me looks like it too can be optimized beyond identifying superstructure using combinatorial algorithms or rules. If you have done this, can you give us a sense of the amount of complexity of the combinatorial rules used? If the fuzzy MILP is an appropriate algorithm to use. On the use of AI, have you considered using random forest or boosted decision trees? Raymond?
Right. Thank you, Hill, for your, I think I can read 4 or 5 questions in there, and I'll try to make this really quick and economical. First, regarding optimization, the standard PNS problem is a special class of MILP problems. Those, as you know, are solved using a standard branch and bound. And P-graph is based on because PNS problems are a special class of MILPs with additional information, that additional information can be used to accelerate the branch and bound optimization and reach solutions faster because of properties of the PNS problem, which I can't go into that in very much detail. Your second question, which I'll try to take up in conjunction with a later question that I can see on screen regarding cursive dimensionality. I just speak of a recent example by the powerhouse research team at Carnegie Mellon University. Just by way of background, this PSE team in CMU traditionally has subscribed to a different school of thought from P-graph. So they would be the last people we would expect to use P-graph. There was a paper from their group published in 2018 where they were trying to look at chemical reaction networks. And what happened was they could see the net observable reaction, and they were trying to deduce the individual reaction steps and what are the possible true reactions taking place on a stepwise basis. And initially they were looking at 30 billion, that's 10 raised to 9, 30 billion alternative reactions in their project. And I can imagine this would have been very stressful for the PhD student who is doing the analysis. But eventually they used P-graph and scaled it down and pruned the scaled down the search, and they found 70 or so potential chemical reactions and eliminating billions of others from further consideration. So that's a practical example of how you can really scale down problem size. And I think it speaks to Juiced's question as well. Now, I'm interested in your last question because you speak of AI, and it was in October of 2019 that I started to speculate. I remember I was having dinner with a friend in Rome, and I asked, you think we can use P-graph for artificial intelligence applications? And it took about 8 months of gestation. I'm happy to note now, even though I'm going out on a limb, I'm working with 2 colleagues from LaSalle, Angeline Lau, who's a mathematician, and Kathleen Aviso, who's had extensive work in P-graph. And we're going to use P-graph for AI applications. And the closest analog that we can find is something called fuzzy combination.
Mel, you can retire early. There's so much job to be done in the Philippines. You can do it remotely, you know. Very much, important for our, elementary, high school, and even at the tertiary
I
levels.
think a
You
lot.
know.
I think a lot. I really
Your visor, you have to extend it, really, to be honest. So anyway, any question on the floor for Mel while we reconnect to Raymond later on. Okay, from Giselle Concepcion. Mel, can you tell us a bit about how to interface visor with this online lab education?
Uh, in a way, yes. It's really just about technology. See, what we're doing with Visor is we've got these instruments that we adopted for science education, right? And so we're using the core, a microprocessor that essentially has this input outputs that control things and measure things. The difference now is this is actually a minor step, which is now to develop devices that not only measure things locally, but they can actually talk to the cloud. What does that mean? You should have devices that have communication systems, such as Wi-Fi, Bluetooth, LoRaWAN, these things. So the good thing about this is when we started Visor, chips with built-in communication systems were not available. Now the technology has advanced significantly that you can get. Look at this, it's $15 at today's prices for something that is twice or three times as powerful as the old stuff. So we can still actually do this. So all of the products that we have at Visor, it's just converting them as it is, converting them into something that we could use in the cloud. So then students in the provinces do not need to go and buy this equipment, right? They simply have to go to the, I don't know, the high school or the central high school or the barangay halls or something like that they have this thing. And so they just maybe play with them using their cell phones or whatever, or laptops. So in some sense, the Visor can actually, this is what I would like to call it Visor 2. So this is the next generation of distributed science experiments.
Okay. Thank you, Mel, for that. Okay, let me read just some comments here from, I think Raimundo Asuncion has one. Let me just read it. Where is it? I'm losing it. Raymond is back. Raymond, sorry. Let me...
Wala tita. Minihan mo kasi yung loob. Oo nga, lahat na.
Can someone put off? Sorry.
So I guess, can you hear me? I have the chat.
Yes, Mel. Yes, Mel.
Sorry. So you mentioned Sean. No? Hello, Sean. So I'm going to read. Thanks for sharing. What are you espousing on collaborate? Is exactly what we're doing in the field of microbiology. We have established a consortium, different universities collaborating to come up with online common laboratory. Well, I don't know much about microbiology, Sean, but I believe that if you've got systems over there that you can actually measure using voltages, voltmeters, or you can have processes that you can actuate remotely. In other words, if you've got processes that you can replace your hands with machines, then that's it. You could do these experiments without any problem at all. Now, in microbiology, I think you would probably have, I think this is actually very interesting because you might have to develop something like this in the field of robotics, where you now have systems, these remote systems that are actually capable of manipulating things, not only stepper motors, but things like bottles and things that will shake and you can change all of that. That is a very sophisticated system, but it is something that I think can be done using this process. But the bottom line is, if you have, I think it's a case-to-case basis. Look at all the experiments that you have and you ask yourself, pwede pa tong gawin ng, can it be done remotely? Do I have to have a physical presence in there? Kung hindi, that's okay. Then you can do it. You know. So I remember the story of Luli Cruz, and when they were talking about, you know, how they were measuring the effect of the conotoxin on the mice. As I remember, they were saying that they would invert the cage and they would count the number of mice dropping down, and they get the statistics and they got what they need. Well, something like this could actually do this. In fact, this is a rhetorical question in one of my discussions with my team. So what it is you have a cage with mice. So natutulog sila. Kung hindi sila natutulog, they're floating around. So you just have a device that will turn this cage around. So the mice that are conscious will probably go and climb up, and those are the ones that are not conscious are probably going to stay in the bottom. And that's something so easy to do with, I don't know, with either computer vision or something. Remember, you have a means to look at it. You have the video, you have the YouTube video, and with YouTube video is the data, and you can do image processing to figure out who's sleeping and who's not. But the whole point of turning the cage, well, that's something you could do remotely. So you can do all sorts of things like this. So another example is, I wanted to know, you know, how much the mungo grows every day. I don't need to be there all the time. I just have a video to take a look at it, maybe time-lapse photography. And then I will put in a system where I'm going to put a little bit of whatever moisture, water, when I see that the moisture is low. All of these things are actually done already. The one thing that we are proposing here is that we do it in a massive scale. That's all. So that's the kind of nebulous idea that I'm trying to propose here.
Okay, thank you, Mel. I know it's worth an extension for an hour. You see, rarely we can have these excellent speakers together. So this is now beyond the script. We wanted to end at exactly 10 o'clock as what we have planned, but I'm happy, and PAASE is happy to extend with our distinguished speakers. Let me just have one more question for you, Mel, before we go back to Raymond. From Rizalinda De Leon. Thank you, Mel, for the great presentation, which I found very informative, especially since UPD Chemical Engineering Department will be developing remote-controlled chemical engineering lab experiments in collaboration with the Electrical and Electrochemical Engineering Institute. While such setups would be accessible for those who have good internet and devices, what would you suggest for students who are beyond internet reach?
That's the $64,000 question. Look, we can only give it to you in retail. Kasi this technology really relies on internet connectivity. So we can offer this as long as you have internet connectivity. It's like oxygen. It's very hard to implement anything for people that may not have oxygen in them. I'm sorry to have such a drastic analogy, but it is what it is, that we need them. In order for them to access, we need the backbone, we need internet, the Wi-Fi. On the other hand, let me turn the table a little bit. You can actually do experiments that you do not need, let's say out in the field. You can do experiments out in the field without internet connectivity. How? Well, there are these other channels of long-range communication. It's like the frequencies, different frequencies. No, I'm not suggesting that we grab the frequencies of ABS-CBN. No, that's not my suggestion. All I'm saying is there are these frequencies available so that people actually can use devices that can communicate. They're low bandwidth, but they're pretty good in communicating data. Let's say out in the field, in the forest, and down to a central location about 5 kilometers away, you can do all of that. Without any internet. We can also use the GSM or the LTE or the 5G system. Ultimately, I'm sure it's going to happen. Not yet in the foreseeable future, but as soon as we get the infrastructure of the phone. If we can have a phone, we can actually do all of this stuff. In fact, the phone system, if we have the good bandwidth brought about by the next generation, we don't need the Wi-Fi at all, so we can access everyone. But for now, Dean, it is what it is. Kailangan, we really need internet connectivity sa ngayon.
Okay. Thank you, Mel. On that note, let us move to Raymond again. He's back. Richmond, can we show questions for Raymond, please? Okay. Let me read the one coming from Mike Romintilla. I think this has not been read, correct? Anyway, thanks for this informative presentation. My interest to apply such tool in multi-hazard risk management. Can you imagine a future PGRAPH application in this problem domain? If yes, what could be the potential limitations of this method to the robustness in such application? Raymond?
Okay, thanks for that question, Mike. I think before I got cut off, I was describing that I'm developing the theoretical aspect of the work on a special class of cognitive maps with two colleagues from LaSalle. What I've been thinking about also is applying that to a current problem, which is COVID-19. And very quickly, let me describe the problem. The problem with human expertise is it comes in pockets. So you would have, for example, people who specialize in viruses or epidemiology being concerned and being knowledgeable about a specific aspect of the problem. And on the other hand, you would have economists and sociologists understanding different aspects of the problem. And there is, of course, a human tendency to look at a complex and wicked problem from the lens that you're comfortable with. And thus, economists would fail perhaps to understand the full hazards of a disease like this. And conversely, people who work with diseases may not grasp the full economic implications. I see PGRAPH essentially as a network assembly algorithm. It's a bit like having pieces of a jigsaw puzzle, which you can then assemble automatically with an algorithm. And this is what we're looking to do, that those pockets of knowledge and sub-networks of understanding how things work within certain disciplines can be assembled into a larger network, so you get a better grasp of what the problem looks like from the grand scale and from different disciplinal perspectives. And perhaps you'll be able to come up with better solutions to things like balancing loss of life with this pandemic. Thank you for that.
Okay, Raymond. Let's have another question from Jus Santos. What are the similarities and perhaps strengths of a PGRAPH over stock and flow model used in system dynamics modeling? Also, how does a PGRAPH handle the so-called curse of dimensionality? I could imagine complex systems would be large scale and highly interdependent. Raymond? Raymond, you're still there? Okay. Anyway, we can pass on that question to him, and he can actually share his answer. So we are very much indeed, happy to have been graced by so many personalities in this particular session. Our academics, researchers from the industry, government. This has generated a lot of interest, perhaps because this is a plenary session about technology. But in the meantime, I'm seeing Raymond back here. Raymond, can you just answer a question from Jus Santos, please? Thank you. Did you get the question, or Richmond, can I have again the question from Juice? Raymond is there. What are the similarities and perhaps strengths of P-graph over stock and flow model used in system dynamic modeling? Also, how does P-graph handle the so-called curse of dimensionality? I could imagine complex systems with a large scale and highly interdependent. Raymond. Okay, we lost Raymond again. Juice, I thought we're done with your disaster. You know, I was about to end that with saying we have actually got away with disaster. You know, but it seems like your question seems to not do not get the response from Raymond. Never mind. I think in the interest of time, can we have received a number of messages for our two speakers, several commendations coming from our participants for Raymond and Mel. Excellent demo, fantastic, Mel, amazing. This app can be used in interactive virtual teaching or learning. Some fun, great app. Great ideas. I know it's, there's just a host of, great talk, Mel. Very engineering talks indeed. I learned a lot of new knowledge from this webinar. Excellent talks. Thank you. Thanks for all speakers for a great session. Great talks. Thanks. Thank you, Raymond, Mel. Thanks everyone. Nice to see familiar names in the attendees. Okay. So under Alato, we will send that to you. So indeed, this has been an amazing morning for everyone. Excellent talks from our co-lectureship awardees from the 2020 to the 2017 and the 2008. Put them together. A 2-hour time would not be indeed enough. So let me just give some reminders on behalf of our board chair of PAASE, Carlito Librilla. With all the happenings, including the excellent lectures at the 40th APAMS, it's time to remind you, our members of PAASE and those prospective members, to have your membership dues in. PAASE, welcomes donations, and we rely on the membership fees. They will be used to fund exciting APAMS meetings and the general operation of the Academy. You can check our website at www.paase.org. Membership fees for lifetime membership, that's 4,000 pesos. Otherwise, that's a yearly 1,000 for members. Outside members, coming out of outside the Philippines, that's a lifetime membership of $400 with a yearly dues. If you are not paying the lifetime fee, that would be $50 per year. So I would like to encourage our colleagues, members of the PAASE, and those prospective members to support, financially, and we welcome donations so that we can actually be able to sustain our voluntary efforts, in bringing science to the masses, to the people. And of course, this is a science for change. And we are fortunate to have members of the PAASE from the US and all over the world connecting with the Filipino scientists here and bring, science closer to the people and to everyone. So this has been really a great day. I would like to thank again our distinguished speakers. Maybe you can show your videos, Juice, Raymond and Mel, of course, this is your plenary session 2 of the 40th PAASE anniversary celebration. This is your 2020th APAMS. Giselle is there, who is our PAASE president, and the host of our members in the US who are actually staying late now. I know in the Eastern it's time, it's over 10 o'clock in the evening, and I know this is worth the wait. Would like to thank Carlito and everyone, you know, for sharing your time. Giselle, our PAASE president, and behind all this, we would like to acknowledge, you know, the services of Mr. Richmond Pancho, who has been, you know, staying very late and early morning, has to wake up, you know, to make sure that all the technical details and the logistical requirements for this APAMS that will run until August 14 will run smoothly. So we cannot say any more, you know, other than thank you, everyone. Thank you, Juice. Thank you, Raymond. Thank you, Mel, and all our participants who have stayed late, you know, in the morning and late in the evening for this wonderful opportunity. You know, so we will continue to engage ourselves, you know, not only during this APAMS event, but in our daily, you know, activities as we are faced with the challenges of this COVID-19 pandemic. Indeed, Mel, you have done a lot of ideas on how we can, you know, address this connectivity and delivering education, especially under these circumstances. And to our industry participants, you have benefited a lot from Raymond's talk on the use of PGRAPH and process, you know, and of course, for our Philippines always faced with disasters and with this pandemic, we have Juice Santos given an excellent idea on how novel, you know, models can be used, you know, to help our decision makers and our researchers. So again, thank you so much. This is Alvin Culaba, your host for today. And now we would like to end the session. Thank you, and we'll see you tomorrow for another exciting 3 parallel sessions. And maybe, Mon, you can just quickly show it. We have another session tomorrow as we continue APAMS 2020 with 3 parallel, you know, exciting sessions to be chaired by several distinguished also scientists from the Philippines and all over the world. So no, it starts at 8 o'clock, runs through maybe 10 to 11 in the morning. Keep up in your schedule, and you know, another engaging morning and evening from the US tomorrow. That's all for today. Thank you, and good morning and good night to the US. Thank you, and adieu. Thanks, everyone. Group, okay. We have taken the photos anyway, so for those who are still there, maybe you can put on your video. We're taking a photo up on screen. So whenever you get the chance to put your video on, please do. We're going to go through, there are about 3 pages of this or 4 pages of this. Richmond, please help me take the photo, please.
Okay.
So that's the first.
May I
Okay.
request everyone to please turn on their webcams, their video feeds. Thank you.
Okay. Please turn on your video, please, just to show your live faces. Okay, so thank you. That's thank you. I'll rest. Friends and colleagues, nice to see you virtually. You know, it's been a long while. You know, we have not seen each other. Okay. So Richmond, just take photos for each page.
All right.
You know, this will be part of our historic celebration of PAASE's 40th year. So again, thank you so much. We'll see you again tomorrow and the succeeding sessions until August 14 of this year. Thank you so much, and God bless.
Good job, Alvin.
Thank you.
Good job, Mel.
Al, you got my message, right?
Yeah,
Let's do
you got it.
something.
Let's talk about it.
I mean, come on.
Yep.
Kayang-kaya
Yeah,
mo
we
yan.
can do this.
Come on.
Kaya natin yan. Yeah.
Maraming pera si Al, Mel. So,
Let's have a competition muna. Okay.
Yeah.
sure, why
Ayun na,
not?
dalawa na.
Pera ni Al. Al, kailangan mo itapos na yung pera. You already
Yes,
talk about it.
oh.
Now is the time to put it out.
Yes, Al,
Ayun
get
ang
your money
pinag-uusapan
out.
na natin. Yeah.
Hindi, gumawa tayo ng
May dalawang kumagat.
Kaya,
Si Sean at saka si Baby Lynn. Ayun, kumagat na. So, I'll do a
Oo,
project with
eh.
them.
kaya natin
That's
yan.
good, that's good.
Alright.
That's good. And then we can do SUCs, guys. Pasok.
Oh, yeah. Giselle, thank you so much. A great session. Excellent, Mel.
So Mel, I
This
look
is-
forward. Really, Vicer too. You're really a frontier.
Oh, well.
Yes.
Yeah,
Implement it. Yes.
marami tayo.
Ah,
Marami tayong pwede i-implement doon. I will try and
So yan talaga yung major concern natin. Major concern ko sa STEM, even at the undergraduate level, yung laboratory training. Mahirap sa biology. Mahirap sa ano.
yeah. Yes, Mel, retire early will assure you your, sustained income. There's just so much you can do here in the
Yeah,
Philippines.
sama ka na
you know.
dito, Mel. Basta
Yeah,
yun,
balik ka na.
Pilipinas.
Well, you can always do that in the US.
I wanted to, but they're not allowing people from America to come to the US.
No, it's okay. Yeah, just manage it from there. We're okay.
14 days
great.
quarantine ka. Oh my God. Yeah.
I'll create a bubble for you. Pa-escort kita sa airport.
Thank you, guys.
Yes.
So hindi naka-attend si Gani Tapang Mel, pero I was in constant communication with him.
But I think can people kind of view the talks again? Meron
Oh
bang-
yeah. It's
Yes, Mel. It's recorded.
Para
para lang,
It's recorded. And we have a YouTube recording as well. So we're going to share it. I'm sure Richmond.
May mga schools kasi
Oh, yes, sure.
never know, kasi yung capstone design, yung thesis nila, you know,
Mhm.
you come up with some sort of tapos itong si Al, we have a little bit of competition. No, we
Mel,
give him,
you see-
kailangan bigyan natin sila ng resources. Kahit $500.
Yeah,
then
Mel,
they-
you seem to have accepted our invitation that you retire and then continue your work for us. Well, we have so much to do for our education here in the country. So, Mel, you will not be out of job for sure. So, Al, myself, Giselle, we will be behind you. So, no problem. You need what?
Of course.
The universities, we will mobilize them.
I've just
don't
sent
worry.
your slides, Mel, to Sec Boy de la Peña. See?
Oh,
yes.
sayang din di ba? Sayang din, you know.
That you appeal
Saka,
to the
eventually, Mel, yung private sector, the private sector
Oo.
sponsors for the labs. I mean, naglabas na ng perang
Kunin
Aboltis,
natin yan,
10 million.
Kunin natin
Then
yan.
we can try to get the Ayalas and everybody else
Well,
to start
I
pitching
don't
in
know
for
about
a
We
vote.
signed a MOA with the PAASE. So that's your role, actually, Al, right?
Yes.
Yeah, champion. Saka
Yes.
ako. Saka,
Mag-
but we
MOA.
need specific projects like this.
Exactly.
You can pitch to them, Giselle.
Oh,
Yeah.
Saan nyo ba
Okay.
humihingi tayo ng pera? Saan natin gagamitin? Ito yun.
Exactly.
Yung mga
Meron tayong
sinasuggest na
project
ganyan.
natin. Meron
mga
tayong
ganyan
group
mga project.
discussion. Meron tayong
Yeah.
group discussion led by Gobet Advincula and Michael Puruganan on STEM education. So,
Great.
Mel, kailangan
Yeah.
nandun ko sa panel.
Mel. Yeah.
Okay? Tapos kumpidahin mo, Al, yung mga private sector para mag-participate doon sa panel sa group
Sige.
discussion.
Okay.
Siyempre,
Sure.
ikaw din.
Yeah.
Okay.
Let's get the
Wonderful.
private sector, especially
Yes.
the feed, PSP, the foundations, to listen to that STEM.
Yeah.
There's
But
so much.
we
that
need- Yeah. Alvin,
We
kasi
need Mel. We need Mel.
ammunition, ideas
No, you
like
don't-
this,
you don't need
examples,
We
no?
need Mel there.
Kailangan ko. I need bullets, guys.
Yeah, I know, Al, if it's our faces that will be there, they might not give, the money.
Yeah.
So let's show Mel's face there.
Sawa na sila sa pagbubuka natin.
Yes, of course.
Slides, no? Tapos now, Vicer, in the cloud. Yun na,
Yes,
major
yes.
transformation.
Labs na nga yan eh, Cloud Labs.
Yeah. Mel, we have so much clouds in the Philippines every day. Nimbus. What clouds do you want? You want to rename a new cloud? So, yes, let's
Yun ang
utilize
talagang
it.
future, eh. That's the future, guys. Talagang
Yeah.
yun na yun eh.
It is.
That's really what
It
we'll
is.
do.
So, matagal ko nang try i-connect si Mel din kila Chris and Marivic Bernido. Kasi they are connected, they're fully supported by SMART. Okay? Tapos nag-umpisa sila syempre sa physics, learning physics as one, right? Dynamic learning for physics. Syempre, yun ang medyo rin madali na ituro nila sa kanilang school, no? But Mel and I think the Bernido should be connected. And then with that, connect with SMART. Okay? So, I think we have a good thing going.
Yeah.
Symbolize the bridges.
Yeah.
Look at your...
Yeah.
So, Alvin, sana dinescribe mo yung
Yes.
bridges. San Juanico linked with the San Francisco.
Ang ganda
Bridge.
niyan.
Ang ganda, no?
Yeah.
Sabi ni Ernie Pernia sa email natin, tawagin natin ang PAASE Solidarity or PAASE Bayanihan. See, let this symbolize PAASE Solidarity between the US and the Philippines or PAASE Bayanihan.
Maybe that will culminate at the end, Giselle.
Yes.
That's something that will, be that would bridge to the PAASE 2021 when the 40th anniversary culminates in the US. So that bridge should complete, from the Philippines to the US. So I think that would be your message, when we
sa session that I hosted, sinabi ko, it's also the bridge between basic research. So meron kaming speakers on molecular and cellular biology, top speakers. Tapos it ended with speakers from UP Manila PGH. What's on the ground there in PGH?
Right.
Yung development ni Ewang, Dr. Wang sa CIBOL, medical devices, and also Dr. Lapitan's program on infections after surgery, monitoring, surveilling.
Yes. Actually, this photo, speaks of so many things. The sea there, the beautiful, sea, and the,
Beautiful.
so very, so I think this really, provides a pathway for the next maybe 40 or more years for PAASE. So we have been, that's why I think, Giselle, we really need to build, a group of people who will sustain, our energy is not, infinite. So we need a new breed of people who will continue. This has been what
I try to do, Alvin. That's why we have 30 new hosts. So there are 30 parallel sessions, and the hosts there are the ones that I thought would be our new leaders, okay? Because by demonstrating that they can come up with their own symposia, mini symposia.
We have never been absent, Giselle. So we are still here.
No. You have to pass
so we are. Well, we are. That's why.
To the new leader, no? And
Yeah.
then
So
there are now
let's.
groups. We have groups based on research expertise. At the same time, we can still be involved in the projects and the advocacies that we are interested in.
Sure.
So that's the whole idea of PAASE.
Yeah.
Okay, so